Here we go. So your homework will be from the book. Okay, textbook 6.2. With any luck, if we go through the examples quick enough, though, you'll probably get most of this done in class. It's not a very long assignment. However, I will pass out the quarterfinal review. There is a study session tomorrow in room K234 from 8 to 12. It's just an open room, basically, with a math teacher that will answer questions, but he's not teaching or lecturing or anything. But if you want to get a head start on the quarterfinal review, which is on Friday, a week from today, then that's a good place to start. It's one of those things that people don't feel like come to school on Saturday, and then during the actual final, they're like, I wish I would have came to school just for a few hours. I would have done a lot better.
Wait,
So,
can you leave early or no?
you can, I believe so, yeah. But just it's more about like this is your final grade. You guys know that this is half of your semester grade, which gets sent to all the colleges you ever want to attend. So it's not something. It's well, I'll just drop by and hang out for a while, and then commit to it, and you'll do a good job. All right. So I'll hand it up before we leave. It's also posted. So let's start here. Negative exponents are blank fractions. What's that?
Positive.
It can also be fractions and decimals. Yeah. All right. So we're going to go do some more practice with polynomials. We'll do some multiplying, distributive property, adding, subtracting. Here's something a little new, though. When we're talking about this, should say polynomials. Talking about polynomials, how do you know if it is a polynomial by definition? And here it is. This is the definition, although this is not what you use when you're trying to figure out if something's a polynomial or not. There's three things you're looking for to figure out if it's not a polynomial. There are three things, okay? 1, 2, 3. We're going to go through them right now. First thing is, if it has a negative exponent, not a polynomial. So no negative exponents. No negative exponents, not a polynomial. Very similarly, negative exponents is any variable on the denominator is a negative exponent. So really this is y to the negative 1. So this is also not a polynomial. So you can say variables on bottom of fraction or as denominator, however you want to say it, not a polynomial. Not a polynomial. So these are basically the same reason, they're just written different ways. Negative exponent, very obvious. Negative exponent because it's underneath on a fraction. So, and the last one right here, square roots. Not a polynomial. Why? Okay. Well, the definition says it has to be a positive, right? And that's what the first two words, if they're negative, whether it's just an obvious negative or indirect negative because it's a denominator. The third one has to do more with the fact that it's an integer. Any square root can be written as a fraction exponent. So square root of x is actually x to the 1/2. So the reason this is not a polynomial is because it's not an integer, which is -1, -2, 1, 2, 3, 4. Has to be a whole number. So those are the three different reasons why you would not have a, I'll just say radicals, why you would not have a polynomial. Okay. So that means the other ones that are remaining, right here, that's a polynomial. That's a polynomial. All positive exponents, right? These are all positive exponents. No variables in denominator, no square roots. Those are polynomials. And it's kind of like one of those things, like, why do you want to know this? Well, if it's a polynomial, we can do certain things. Just like if it's a function, we can solve certain problems that are functions. But if they're not functions, we can't really work with them. If they're not polynomials, there's some things we don't want to do. So the first thing is figure out, is it or is it not a polynomial? All right. Lastly, the degree. What is the degree? What is the degree? Okay, that's right down here. What does that mean? Okay. That is the highest exponent of the polynomial. So if you have a polynomial, the highest exponent is the degree. Okay. I'll say largest. That would be technically correct. Largest exponent. All right. Now, why do we need to know the degree? Why is that worth even saying? Why would we want to look at this and say, oh, the highest degree is 5? Why is that important? Okay, so let's link this to actual purpose. The degree also tells you how many possible solutions. So remember when we're doing all those quadratics, that was like x squared, plus 5x minus 6. Well, this is the degree. It's 2. How many possible solutions are there for this? Yeah, 2 complex or 2 real. The highest possible number of solutions is 2. That has to do because of the degree. The highest exponent is 2. So as we start solving things that are to the 4th power, to the 3rd power, to the 5th power, we know before we even start them that there's 5 possible solutions if the polynomial is to the 5th power. Good. All right. So any clarifications needed on this? Okay. Know those 3 criteria right up there, and know what degree means. Know what it is, and know what it means. Know that it's the largest exponent, but it tells you how many solutions. So those 3 points are the most important, and that's the first part of your homework. All right, the next part is more review. Just straightforward, add, subtract some polynomials. That's it. So, of course, if you have a negative, make sure you distribute. And this is going to be the, most people say this is the easy part. Just don't mistake adding, subtracting rules with multiplying rules. So you guys just got done doing a bunch of multiplying. All right, but don't start using that rule on everything. So we did a bunch of stuff where you add the exponents together. We're adding, subtracting now. You don't add the exponents. You add and subtract the coefficients. So a negative x squared and a negative x squared isn't positive x to the 4th. It's negative 2x squared. So when you're adding, subtracting, you actually work with the coefficients. Negative 1 and negative 1 makes negative 2. The exponent stays the same. Okay. Negative 3x, negative 2x is negative 5x. And then positive 4 and negative 5 is minus 1. So similar to yesterday, it's the repeated steps, same rules over and over, but use the right rule at the right time. Good. Let's see here. I think we're okay there. Okay, that's the adding, subtracting. Let's look at a little bit of multiplying. So are you going to add exponents on this problem? Yeah, because it's multiplying. So switching gears from one rule to another. What is 4/3 times 6? 8. Now you see how fast that calculation should be. This is where you want to be at when multiplying fractions. It shouldn't be as pause of, well, I'm not sure. If it is, don't trust yourself. Just use a calculator. You have it. It does fractions, so use it. And then x to the second times x to the second is x to the fourth. So now it's okay to add the exponents together because we're multiplying. But unfortunately, the most common mistake on this problem would probably be the fractions. So if you have any hesitation, if you're not getting the answer, if I say what's 4/3 times 9 and you don't have it in your mind like in 2 seconds, maybe a calculator is a good option. So what's 4/3 times 9? 12. X to the third. So there's a squared here, and if there is no exponent, it's a 1. Alright, good. Lastly, we have 4/3 times 12.
Negative 16.
And then x to the second. Question?
On our homework last night, when a variable with an exponent was outside the parentheses, you had to multiply it. So does that rule completely cancel out if there's a number before the variable?
Not sure what you mean.
Now, when we combine the x's, we add them. But on our homework last night, if there was a variable outside the parentheses with an exponent, we had to multiply the exponents.
Oh yeah, it is multiplying if it's on the outside. That's true. But yeah, if it's just straight adding and subtracting like this here, then yeah, you work with the coefficients and that's
Well,
it.
the one we just did, we added.
No, we just multiplied. We didn't add anything together.
But then the 12 would be x to the second, because 2 times 1 is 1. I mean 2, not 3.
We're adding the exponents. When you multiply, you add exponents. That's always been the case.
When I
Yeah.
on the homework last night, when there was parentheses and there was an exponent on the outside,
Yeah,
But it was just.
we multiplied.
But it was just an extension.
Yeah.
multiplied the multiplied
So
the-
you're talking about like 2x like squared and then to the third.
Yeah.
Yeah, so there's two rules from yesterday. There was x to the third times x to the second.
Oh, so you can only.
That's when we added, and then if there are two exponents, that's when we multiplied.
Okay, so if there's. Okay, I got it.
So it's again, it goes back to knowing when to use which rule.
Alright.
Yeah. Good question. That's what all this whole chapter is all about: is when to use what rule. Alright, so let's see here. Yeah, give this a shot. Go ahead and write this down. Try it on your own, just to make sure we're understanding everything. I'm going to put up an answer, and I want you to see if you can find something that's incorrect about it.
Positive. What's your negative then?
And the 22 should be squared.
And then the 40 should have the A.
22 in the middle, just in case you didn't see it, it should be A squared. Adam.
Negative 40. I think I have the A last one.
Yeah,
Get your answer.
negative 40 should have both.
What can you find that's wrong on this?
Everything is wrong.
You did the A.
So, yeah, these are actually common mistakes. For some reason, I still see a negative when I see a negative times a negative. And right here, what's the common mistake? Yeah, that since there's no exponents, they forget to actually, there's two of them here, and that's why you get squared. So even if there's no exponent, if you happen to get 22a, just put little ones on anything without an exponent, and that'll help you remember. And the last one, what's missing here? And why do you think, any guesses on why people forget that often? There's no a on the 20, but also with our quadratics we just finished, what did it look like at the end of every problem? It was always a number at the end of end of the expression or the equation. So we're so used to seeing this and being okay with just a number at the end, so that we just kind of forget, and because that looks weird if there was a variable. We're just used to having it look this way. So again, just switch gears. It's kind of a little bit different from what we've been doing. Good. Lastly, multiplying by a binomial or trinomial. Lots of ways of doing this. You can distribute 1, 2, 3, 4, 5, 6 times, and then combine all the like terms, and it'll be just a long string of terms. Or use the box method, which would be a little bit more organized, and it lines up all the like terms on a diagonal for you. So anytime you're doing anything with a trinomial or more, I recommend this, just because all the like terms line up for you. Whereas if it's in a straight line, you have to kind of scan through one long math sentence for just the right thing. And again, if you forget about this, put those exponents there. Alright, go ahead and see what you get. You can try it out, see what you get. Okay, as I mentioned earlier, nice thing about this method, the diagonals will give us the like terms. We don't have to go looking for them. So we're left with just x to the third minus 64. That's it. Does that always happen where everything cancels out? No, but this is actually a special problem. This could be rewritten as x to the third minus 4 to the third. This is an example of a difference of cubes. You guys know about difference of squares. This is a difference of cubes, and you can see the format which it factors to. So if you have x to the third minus 4 to the third, it factors to x minus 4 and then x squared plus 4x plus 16. So the sign is opposite, and then you square it. That'll give us how it factors. So you're going to be factoring. You guys know all the box method for factoring quadratics, anything to the second power. We're stepping it up and saying, well, how do you factor something to the fourth power, fifth power? How do you factor a difference of cubes, a sum of cubes? Okay, kind of similar, because you guys have seen a difference of squares before, like x squared minus 4, you know, is x plus 2, x minus 2. So you're somewhat familiar with the idea that there are some shortcuts for certain problems. So this is one of those that you'll be learning, difference of cubes. Okay? It's not quite as simple. It's not x plus 4, x minus 4, but there is a pattern we can use. So that's something we'll be looking at next week a little bit more closely. Okay. One more time, why is this not a polynomial right here? Because this is really what? X to the 1/2, which is not a positive integer. Alright. Let's have you guys start your homework. And again, it's going to ask you if it's a polynomial and then state the degree. That's the first part. And then afterwards, it's just simplify. Should be able to start, maybe even finish this whole thing in class. Also, let me pass out the final review so you have that.